Hi, in this video, this is a GCSE higher paper walkthrough. As always, please do stop the video, have a go at each of the questions. If you're not sure about anything, always add a comment below. I'll always come back to you. I look forward to seeing you inside the video. Okay, so in this video, we're going to be looking at the Maths Higher Tier Paper 2, and it's for Edexcel from June 2019. Please do stop the video, have a go at each of the questions. So let's move on then to question number 1, which deals with inequalities. So effectively, I would normally treat this almost the same as a normal linear equation. The whole idea is I need to get n's on one side and numbers on the other. So what I'm going to do is I'm going to minus 11n from both sides of the equation. That's going to give me 3n is greater than 6. Okay, and then I need to divide through by 3. So if I divide both sides through by 3, I get n is greater than 2, which is actually the answer to that particular question. Okay, hopefully that's all right for you. Let's move on to part 2, which is where they ask you to draw a number line. Now the problem you've got with this is you've got this x plus 3. So what I'm going to do is I'm going to minus 3 from both sides of the equation. So I've got minus 2 minus 3 is going to give me minus 5, and that's going to be less than x, which is less than or equal to 4 minus 3 is positive 1. So basically all we're doing is drawing on the number line something between minus 5 and positive 1. Now, because it includes 1, I'm going to fill in this little circle here, and it excludes minus 5 over here, so I'm going to leave that empty. And basically, that would be the answer to the question. Okay, let's move on then to question number 3, which is fairly straightforward. It's just asking us to draw a line on a grid. So in order to do that, what we need to do is work out values of y for the different values of x. And it does say from minus 2 to 4. So what I would normally do with this is draw myself a little grid, something like this. I've got x along here, and I've got y, and I've got x values from minus 2, minus 1, 0, 1, 2, 3 and 4. Okay, now what I normally do myself is I actually start with the positive numbers, because it's just kind of much easier to plug these values in when they're positive. So when x is 0, 2 times 0 is 0, and then I've got minus 3, so my value of y must be minus 3. When x is 1, 2 times 1 is 2, 2 minus 3 is going to be minus 1. And basically we can carry on in that particular vein. So when x is 4, 2 times 4 is going to be 8, 8 minus 3 is going to be 5. Okay, and the other ones should also slot into place for you as well. Okay, so you could actually draw the line using just those coordinates, not worry about the negative ones, fill them in afterwards if you wanted to, but just for the sake of the video, I would say 2 times minus 1 is minus 2, and minus 2 minus 3 is minus 5. Minus 2 times 2 is minus 4. Minus 4 times minus 3 is going to be minus 7. Okay, that will allow us then to actually draw the line just by plotting the coordinates. So 0 minus 3 is going to go down here. Okay, I'll just move this up on the screen. Okay, so that's going to be down there. 1 minus 1 is going to be here. 2, 1 is here. 3, 3 is up here. And 4, 5 is going to be over here. And as I mentioned before, that would be sufficient to draw the straight line. However, minus 1 minus 5 is going to be here, and then minus 2 minus 7 is here. And you would just simply join up all of those dots using a ruler, and that would be the answer to that particular question. Okay, hopefully that's all right for you. Let's move on then to question number 3, which is a stratified sample type question. So in this, what we're being given is just a bunch of data, really a bunch of information about Hannah, who's preparing a day trip. And this is a sample of the 30 students of where they want to go. So it says, work out how many of the 195 students you think will want to go to the theme park. Well, basically the sample is 10, out of a group of 30. So what we're basically saying is 10 out of 30 wanted to go to the theme park. So therefore, of the 195 students that are available for the trip, we think that's going to be 65 students. So the answer to this particular first question is going to be 65 students. Okay, then it says, and very typically with these sorts of questions, there's a bit of a kind of a throwaway one marker at the end. It says state any assumption that you made and explain how this might affect your answer. Well, there's two assumptions really. So the first one would be that you're assuming that all 195 students want one of the trips. Okay, sorry about my writing here. Okay, so at the moment we've said theme park, theatre, sports centre and seaside. Well, somebody else might want to go to a film or something like that. Okay, so it's assuming all 195 students want one of the trips. And I think also it assumes that all 195 students are going on this trip. Okay, because it might be that they might not want to go because they've got other stuff to do. I don't know. Okay, hopefully that's all right for you. Let's move on then to question number 4, which is a fairly traditional kind of volume type question. So in this particular one, we're being asked to work out the volume that a container is holding when it's actually 2/3 full of water. So we've got that kind of look to it. Okay, so basically the volume is going to be equal to I'm just going to put this in centimeters cubed. It's going to equal 2/3 of basically the area multiplied the depth. Now I'm just going to do this on the video as 30 times 6 times 19. So basically this is the volume, it's the area multiplied by the depth, or the base multiplied by the height, whichever way you want to say it. But we've got 2/3 full, so therefore we need to work that out. Now it is a calculator paper, so it should be relatively straightforward to do that, and you should get something like 2/3 of 3420. Okay, and when you calculate that out, you're going to get 2280. Now the important thing, and the reason I put centimeters cubed here, is because you'll notice that the cup holds 275 milliliters of water. Well, it just so happens that 1 centimeter cubed equals 1 milliliter. So therefore we've actually got 2280 milliliters. So always with these, it's very much worthwhile checking the units. Okay, so we've got 2280 milliliters. Each cup holds that. How many cups? Well, it's how many lots of 275 are in 2280, and it's 8.290 with that bit recurring. So in answer to the question, it's actually going to be 8 cups of water, and that would be the answer to that. Just be very careful those sorts of questions. You do need to check the units. Okay, so let's move on to the next question, which is a SohCahToa type question. So if you're not familiar with trigonometry, it would be worthwhile having a look at some of the worksheets on 3-Minute Maths, and that will give you some practice questions. So calculate the length AB. Well, basically it's a right angle triangle, therefore we can use this kind of calculation. And basically what we're doing is we're choosing one of these ratios. Now if we look at this 38 degrees, opposite the 38 degrees is going to be AB. The hypotenuse is always the longest side of a right angle triangle, and the one that's left is the adjacent. Okay, so we're wanting to find out the opposite, and we know the hypotenuse and we know the angle. So the ratio I'm going to choose is this one because I know the angle, I know the hypotenuse, and I'm trying to find out the opposite. So therefore what we're saying is the sine of 38 degrees equals the opposite divided by the hypotenuse. Okay, well the opposite is going to be AB, and the hypotenuse is going to be 16. So we're in a position now that we know this is equal to this. So if we want AB, I'm going to multiply through by 16. So I get the sine of 38 multiplied by 16, and that equals the opposite. Put that into a calculator and you're going to get 9.85058 which is the opposite. You'll notice that it does actually say give your answer correct to 2 decimal places. So in answer to this particular question, the second decimal place is 5. It's not going to change because that's less than 5 afterwards. So therefore it should be 9.85, and that would be the answer to that particular question. Okay, let's move on then to question number 6. This is one of these new kind of topics for the new specification. A bit of an odd one really, but Sally's using a calculator to work out the value of the number y. A calculator, it begins 8.3, completely error interval. Well, the value of y has to be greater than or equal to 8.3, and it has to be less than 8.4, and that's pretty much it. I don't really know how to kind of add anything to that, but if you can imagine the display on a calculator, that's what it would have to read in order for it to be within an error interval. Okay, so let's move on then to question number 7, which is slightly safer ground. We're looking here at a ratio question, and in this particular one we've got 4 people who are sharing £360. Okay, so let's have a look at what's actually happening in the word problem. So we've got A to B to C to D. Okay, now it says Abby to Ben gets 2 to 7. Well, that's okay. And then it says Chloe and Dinesh get 1.5 times the amount Abby gets. Well, if Abby gets 2, then 1.5 times 2 is going to be 3. So therefore, Chloe and Dinesh must get 3 each. Hopefully that's okay for you. So it basically means if they shared £15, Abby would get £2, Ben would get 7, Chloe would get 3, and Dinesh would get 3. However, they're not. They're sharing £360, which is basically 24 times bigger. So all we've got to do really is multiply each of these out by 24. So Abby's getting £48, Ben is getting £168, Chloe is getting 72, and Dinesh is getting 72 as well. So in order to answer this particular question, the amount of money that Ben gets is going to be £168. I'll just write that at the bottom there for you. Okay, hopefully that's all right for you. And then we've got these 2 small questions right at the very bottom of the page here, where we're asked to write these numbers in standard form first and then as an ordinary number. So in standard form, the decimal point has moved 1, 2, 3 places in the negative direction. So it would be 5.62 times 10 to the power of minus 3. Okay, this number as an ordinary number, well, it's telling us 3 decimal places in the positive direction. So that's going to be 1452. So it's moved 1452, and that's the answer to that particular question. Okay, let's move on then to question number 9. I'm going to aim, as I mentioned, for this video to be about 20 minutes in length. Should give you about an hour's worth of fairly good quality revision. Please do visit 3 Minute Maths, and that will give you quite a few worksheets on these sorts of questions. Okay, so circumference of circle B is 90% of the circumference of circle A. Find the ratio of the area to the area. Okay, so let's have a look at that. So basically, if the circumference is 100% and 90%, we're really talking about length. It's a linear relationship. Okay, we don't need to worry about actually calculating it, therefore we're not going to use the formula. So what we're saying is it's a length, which normally I would use as standard K. Okay, so what we've got here for circle A, if it's 100, then circle B is going to be 90, and it's that kind of ratio. Now, if I reduce that to 10 to 9, that's still this length K. It's the scale factor. Okay, let's look at what happens when we get K squared, which is the area scale factor. Well, we K squared this, which is going to be 100, and this, which is going to be 81. And actually, that's the answer to that particular question. It's a ratio of 100 to 81. Okay, very similar with part B of the question. Square E has sides of this and length of that. Okay, the area of square E, the area. So this is a K squared. What we're basically saying is the area, which is K squared, of E to F is going to be equal to 144 when this is 100, because if it's 44 times greater, then it must be 100 plus 44, yeah, or times 144 times 1.44, whichever way you work it out. Now, if I look then at the length ratio, which is what I'm looking for here, is I'm going to basically square root it. So the length ratio is going to be equal to k, which is equals the square root of 144, which is 12, and the square root of 100, which is 10. Therefore, in its simplified form, I can write that as 6 to 5, which would be the answer to that particular question. So, little bit tricky, that one. Please do, if you're not sure about anything, always add a comment below, and I'll try to point you in the right direction. I'll give you a little bit of extra support on that one. Okay, let's move on then to question number 10, which is a probability tree. Very, very popular at the moment, seems to be. And it says the probability of the train will be late on any day. So it doesn't matter whether it's a Thursday or a Friday. Any day it's going to be 15% late, okay, which I don't think is going to make commuters particularly happy, and I'm sure is not reflective of the real world. So not late is going to be 0.85. In other words, 85% of the time it's not late. But it doesn't matter whether it's a Thursday or a Friday or any other day of the week. It's exactly the same probability of a train being late. Okay, so if we then want to use this information to work out the probability the train will be late on at least one of the days, we've got to look at the outcomes. So the outcomes that we're interested in are going to be late, late, late and not late, not late and late, and then not late and not late we're not too worried about. So basically we've got to work out these outcomes and then add them all together. So it's a case really of just multiplying along the branches, as you know from working with probability trees. So I've got late is equal to 0.15 times 0.15. Now I'm going to leave this as a decimal. We are using, it is a calculator paper, so if it's calculator paper then it's okay. You can just leave these things as decimals, although it is arguable that it's easier to calculate with fractions. Okay, so I'm just filling this in here, not late, and late is going to be 0.85 multiplied by 0.15. That again equals 0.1275. So we add all of that up together and we're going to get 0.2775, and that would be the answer to question number 10. Okay, hopefully that's all right for you. Okay, we're 17 minutes into the video. I think what we'll do is we'll do the next question, which is question number 11, which is a frequency table type video. Let's have a look at some of the information there. Now, this is actually spread across 2 sheets of paper, so hopefully I'll be able to get this across okay. So the first thing is that we're being asked to complete the cumulative frequency table. Well, cumulative frequency is, as it sounds really, is that what we're doing is we're adding these up. So when we get to the end of it, we're going to have 80 office workers. So the first group is 5 because it's the same. However, the second group is going to be between 0 and 40 minutes. So it's 0 to 40 minutes. So it's actually going to be 35 people. And again, 0 to 60 minutes, well, that's going to be 0 to 60. It's all of these added up. And basically, it's just really just working through this until you get to a point where at the end you've added up all of these columns and you've got 80 people, which we know from the actual text that there are 80 people who take time to get into work. Okay, so the next part of this then, part B, is to actually plot that onto the grid. Now, it's going to be a little bit tricky to show you, but basically what we're doing is we're plotting, because it's cumulative frequency, it's going to be frequency, which is 5 in this particular case, to the end. Okay, so it's 20 minutes, and then 30 frequency, I beg your pardon, I'm looking at the wrong one, 5 to 20 minutes, 35 to 40 minutes, 55 to 60 minutes, 70 to 80 minutes, and so on. You'll see what I mean as I fill out the actual grid itself. So the first one is going to be 20 to 5 minutes, which is going to be here. The second one is going to be 40 minutes to a cumulative frequency of 35, which is going to be over here. And then we're going to have 60 minutes to a cumulative frequency of 55, which is there. And then, where are we? 80 minutes to 70. This is quite difficult across two particular screens, but we're getting there. Okay, 100 to 78. And very typically you'll see with these, it starts to kind of flatten off. So what is nice about cumulative frequency is they've got this kind of nice curve that goes something like that. Okay, so hopefully that's all right for you. And then it says the final question of this particular question number 11 is use your graph to find an estimate for the percentage of those office workers who take more than 90 minutes to get to work. Well, if we look at the actual graph, what we're interested in is this group here. So it's anybody who took more than 90 minutes. It's anybody after there. So if we look at this, it's actually allows us to identify that there's actually 6 people between 74 and 80. So 6 people take longer than 90 minutes. So as a percentage, that's going to be 6 out of 80 people multiplied by 100 to get the percentage is going to be 7.5. So therefore 7.5% of people made it in greater than 90 minutes on their commute, which I don't think I'd like to do that at all. Okay, hopefully that's been all right for you. It's a 20-minute video. It's probably a good point to stop at this point. I'm going to start the next video from question number 12 onwards, and I look forward to seeing you inside the next video.